Okay, remember we started this one in the last video, but I said we needed another example before we could do this because we have to resolve our vectors here and use some trig. So we have our inclined plane. We're not supposed to be drawing it on a free body diagram, but just to show you the coordinate system, I'm going to draw where our plane is. So I have my force normal that is perpendicular to my plane, and then I have my mg here. So when I draw the sum of my forces for this problem, I'm going to do my forces that are parallel to the plane, and then I'm going to do my sum of forces that are perpendicular to the plane. So my sum of forces, we'll do the perpendicular one first, is going to be force normal, right? That's perpendicular to the plane. And also this part of my mg. So if this angle in here is 20 degrees, right, this angle in here is also 20 degrees. And I've got this leg of my triangle is going to be adjacent to my angle. So I'm going to be using cosine. So if I were to, we have my hypotenuse, which is mg. I'm looking for the cosine component and my angle. All right, this is the sum of my forces in the perpendicular to my plane. Parallel to my plane is just this part of my mg. If I were to take this part, pick it up and place it on the plane, it would be parallel to the plane. In this case, I'm using my opposite leg. So my opposite leg is going to be my hypotenuse sine theta. And there's only this one force, right? There's nothing balancing that out. It's not in equilibrium. I'm going to set it equal to ma. So these are my two equations for this object that is sliding down an inclined plane. Right? If I had friction, I would draw my frictional force along the incline, right? And maybe it'd be moving with a constant velocity, and I would set this equal to 0, but it is not, and we are accelerating down the inclined plane, right? This thing is on a frictionless inclined plane, and it's going to be increasing its speed. It's going to be accelerating, just like our first few labs with the marble down the inclined plane. Okay, so we have our 20 degrees. We have our mass. Our theta is 20 degrees. Our mass is 20 kilograms. So I can figure out what my acceleration is. So in this case, my masses cancel out because they're on both sides of my equation. So it's just going to be 10 sine 20 is equal to my acceleration. Again, I don't have a calculator, so I don't know what sine 20 is, but you would plug in your calculator sine 20 times 10, and that would give you your acceleration. Something less than 10, right? Because sine of anything is going to be less than 1. And the quickest we're going to be accelerating without an applied force is going to be something less than 10. All right, our force normal in this case is not equal to mg down, right? Our force normal in this case is going to be equal to mg cosine theta. So my mass is 20 times g, which is 10, cosine of 20 degrees, which would give me my force normal. And again, I don't have a calculator, so I can't solve what that is, but this is how you would solve that problem. I should get myself a calculator before I try these. All right, I'm going to do one more